In this lesson, we're going to look at writing some more complex functions, functions that take more than one parameter. So let's start by writing a program that eventually is going to require the use of a function. So we're going to have three numbers, and we want to determine which of those is the maximum value. So we need to prompt the user to enter the numbers. We'll do that first. Get number 2. And then finally, get the third number. In this example, we're going to use the function before we declare it, which may seem odd, but we'll call it bottom-up programming, where we start at the bottom, the running program, and then work our way up to the function that actually calls it. And there's our output. So now we need to write a function called maximum, since that's what we named it, that takes 3 integer values and returns the largest or the maximum value of those 3. So we come up to our global area. The return data type for the function is going to be integer, since we're working with integers. We know what the name of the function is going to be, maximum, and we know that it's going to have 3 int or integer parameters. And we'll just call them num1, num2, and num3. So we open the body of the function, and this will just be a series of if statements. Well, first of all, we're going to create a variable called largest that we're going to assign the largest value into. And what we're going to do is we're going to compare num1 and num2, store the largest value in the variable largest, and then compare num3 with largest, and exchange those if num3 is larger than largest, or just leave it the same and return that value. So here's the code. We write if num1 is greater than num2, largest is equal to num1, else largest is equal to num2. Then we have another if statement that says if num3 is greater than largest, then largest is equal to num3. Otherwise, we don't have to do anything because the largest value is in the right variable. So we can just return largest. That's our return value for the function. Close off the function value, and we're ready to test it to see if it works. So we'll build and run the program. Put a couple of numbers in there, 23, 45, 12, and the maximum value is 45. And we need to try the function with the largest value in each of the other 2 places as well. So we're going to run it again, and we'll say 10, 20, 30, and it found the largest value in the 3rd spot, and we'll run it one more time. And there we go. So I feel pretty confident that that function works. So a function that takes multiple parameters is really no different than a function with one parameter. You just have to list out the other parameters with commas, as we've done here in the function definition, and then just make sure you use them correctly when you call the function down below. So we come down to the calling program and check to make sure that the 3 arguments to the function, number 1, number 2, and number 3, match the parameters, both in number. There's 3 parameters, so there has to be 3 arguments, and in type, all 3 of the parameters are integer, and all 3 of the arguments are integer. So everything's correct. Of course, we knew that because the program ran. If there was a problem, let's look at that very quickly. What if we accidentally change the 3rd parameter of our function to double for whatever reason, and then try to run the program? You notice that it worked, and it only worked because in C++, data types can kind of go in for each other. Had we had a different type of function where we mixed data types, say with strings and numbers, then we would have had a problem. So for numeric functions, a lot of times you can mix the data types, but in other situations you won't be able to do that. All right, let's look at another type of multi-parameter function, but it's going to be a little bit different. What we're going to do is we're going to start out by defining a function that takes one parameter. we want to write a function that converts a Fahrenheit value to a Celsius value. So it's going to take a double temperature as its argument. And we're going to write this as a one-liner. We're going to write return, and we need the formula that converts Fahrenheit to Celsius, and that is temp minus 32, and we'll declare it as a float, times 5/9. And that's it. Let's scroll down, comment out our old program. And create a new program to use with this Fahrenheit to Celsius function. So we'll create a double var temp and Celsius. Prompt the user to enter a Fahrenheit temperature. And then write Celsius is equal to F to C var temp. That's calling the F to C function with the value stored in the var temp variable and assigning the return value of the function into the Celsius variable. Then we want to write out the results, so we'll write cout var temp Fahrenheit is equal to, then drop down to the next line, Celsius indel. Okay, now we're ready to build and run the program and test the function to see if it works. Enter a Fahrenheit temperature. We'll try one that we know, 212, should be 100 Celsius, and it is. Let's run it one more time. That was boiling. Let's try freezing. 32 Fahrenheit should be 0 Celsius, and it is. For our next example, let's work the other way. And let's go from Celsius to Fahrenheit, so we'll write it the very same way. The return value is double. The function name is C to F this time. Our parameter is a temperature, which is a double. Our function body consists of the return statement followed by the formula to convert Celsius to Fahrenheit, which is temp times 9.0 divided by 5.0 plus 32.0. We have another parenthesis there, close it off. Close off the function definition. Let's come down to our main program and add some code to test it. We can comment out these lines. And we'll write a new prompt. Enter a Celsius temperature. CN Celsius. And then we'll say var temp is equal to C to F Celsius. Then we can display the result. We'll say cout Celsius is equal to, up down to the next line, var temp Fahrenheit indel. Okay, we're ready to build and run. We'll use the same values. 100 Celsius should be 212 Fahrenheit, and it is. Try it again. This time we'll enter 0 Celsius, and that should be 32 Fahrenheit. So that function works as well. For our last example, let's look at a function that actually calls these two functions to demonstrate the fact that function calls can be contained inside other function calls. So what we want to do here is write a generalized temperature conversion function that takes a temperature and a scale to convert to and returns the converted function. So we'll come up to the global area to begin writing it. It's going to return a double. We'll call this convert temp. And it will take two parameters, a temperature and a char scale, being a letter either F or C that we're going to convert to. So we'll write this as a if statement that says if, or actually an if-else if statement that says if scale is equal to C, and we want to convert to Celsius, then we're going to call F to C, we're going to return the call to F to C with temp. else if scale is equal to f, return C to f temp. Notice here that I've used two return statements in a single function, and that's perfectly acceptable. Only one of them is going to be actually executed, so we're meeting the requirement that the function have a return statement. In years past, using more than one return statement was frowned upon, but that led to extra code because we'd have to create a variable like return temp and assign the conversion to that variable and then return, which seems silly when it's easy to follow the flow of this function, that if scale is equal to C, we're going to return this one way. Otherwise, if scale is equal to f, we're going to return another way. So we'll use two return statements in this function. So let's come back to the main program to test it. We'll comment out our old values there, comment out this code, and write a new batch of code to test our new function. So we need some new variables, so we'll create double temp and converted temp. And then we need a char for the scale, so we'll call that temp scale. So the first thing we need to do is prompt the user, enter a temperature and a scale to convert to. Cn temp scale. We might have also put in a little template to show the user how to do it, but we'll assume that they know there's got to be a space between the temperature and the scale. Then we're going to call the function with those two values, so convert temp, open parenthesis, temp scale, semicolon, and then we'll write a cout statement. The converted temperature is converted temp, put a period at the end and an end to L. Okay. Let's build and run and test it. We'll work with what we know. So let's say we want to go from Celsius to Fahrenheit. So that should be 212. Very good. Let's run it again. This time let's go from Fahrenheit to Celsius, and that's 0. So since we knew the functions worked previously, testing it was really most to make sure that our inputs got in correctly and that they got into the functions and were returned. I can't emphasize enough the importance of using functions in your program. In the rest of the course, I'll use functions quite a bit, although not every time, because sometimes I can't make a point by using a function. But in general, in your programs, you should always look for opportunities to use functions and use them as often as you can.